Hello everyone, welcome to day 7 of Leetcode May challenge. Today we have question number 456, that is 132 pattern. So in this question, given an array of n integer nums, a 132 pattern is a subsequence of 3 integers nums of I, nums of j, nums of k such that I is less than j and j is less than k, and nums of I is less than nums of k and nums of k is less than nums of j. We have to return true if there is a 132 pattern in nums, otherwise written false. Let's understand this question. So what in the question, suppose this is the array which we have given, and in this array we have to find 132 pattern. So what is this 132 pattern and what things all about is, suppose if we plot this thing, so 3 will somewhat come here, and then we have 1 over here, and then this is 4, and then we have 2. So we have to find, this is our I, this is our j, and this is our k. So we have to find where the nums of I should be less than nums of k, and k should be less than nums of j, or the nums is the name of the array, we can say array. Okay, so in this n of I is this r1, n is like basically the name of the array, j is our 4, and 2 is our kth index value. Okay, so we have to find this kind of pattern. If we get this kind of pattern, we have to return false. So basically this was our 1, this was our 4, and this was our 2. So we have to find this kind of pattern where this value lies between 1 and 4. And if we found this kind of pattern in our whole array, we have to return true, otherwise we have to return false. Okay, let's see this example. 1, 2, 3 and 4. So this is somewhat 1 will come here, this is our 1, and then if we'll plot this, 2 will come somewhat here, and then we have 3, and again then we have 4. Of course there is no pattern which will satisfy this property. This is our main property for this question, because as all of this all of these numbers are in increasing order, so we cannot found this kind of mountain. So obviously if we have the the array which is in this order, our method will return false. So this is not the happy case, this one was the happy case. Let's see the other example. If we have this example, let's draw it. This is 1. Okay, this is 1. Then we have 3. Then we have 2. Then we have 7. Then we have 9, that is the maximum element. Then we have 4. Little up we have 5, and then little up we have 8. In this case, what we have to do is, first thing is we have to find the maximum element, because maximum element is there, and then we have to find the second maximum, which will be the right side of the maximum, and the least, which will in the left side of this maximum element. So from this whole array, our maximum element is 9. So this is our peak value, which is 9, and in the right side of the 9 we have to find the second maximum value. So in the right side of the 9, our second maximum is 8, and in the left side of the 9 we have to find the minimum value. So in the left side of the 9 we have minimum value out of 1327 is 1. So this, so if we see 1, 9 and 8, so 8 will lie between 1 and 9. So this pattern is the 132 pattern which we want, and in this case our answer will be, our method will return the answer true. Now the thing is how we are going to implement it. Let's see it. For this what we will do, we will create an integer stack. We will create a variable called second maximum, and we will initialize it with -infinity, and in an array we will traverse from right to left, and we will find the second maximum in this whole array. So let's see. First we got 8, so as there is nothing in the array, so no comparison can be done, so we will push add in our array, and then we will iterate further. Now we are on index, second last index, and has the value 5. As 5 is less than the value present at the peak of the index, so we will just simply push 5 in our stack. Then we will move to 4. As 4 is less than the value present at the peak of the index, so we will just simply add 4. And then we saw 9. So 9 is greater than the value present at the peak of the index, so we will remove the element present at the peak and compare it with the second maximum. So if 4 is greater than -infinity, so we will update the second maximum value by 4, and this we will check for all the element present in the array, like till this stack is not empty. Yeah, all the element present in the stack. So now 5 is 5 greater than 4? Yes, we are going to pop 5, and then we will going to compare it. So we got the second maximum 4, like 5 is greater than 4, then we will add it. We will again pop 8, compare, so 8 is greater than 5, so our second maximum now become 8, and we will now push 9 in the stack. So there is only one element now in this stack, that is 9. Then we will iterate further. We got 7 less than 9, add it in the array. Then we got 2 less than 7, add it in the array. Then we iterate further. We got 3 greater than 2. Then we will pop it out and compare it with the second maximum. So we already have 8, no value will change, we will just push 3. Then we saw 1, so 1 is less than 3, add it in the array, and we will get our answer. So basically, you know how things are working. We already know that the 9th is the largest element, or 9th is the largest element, or our kth value we can say, and here we will get our j value, that is the second maximum, that is 8, we got it. And now as in this stack there, like second maximum is not updated, so obviously in the left side of this largest value we will get only the values those who are less than the second maximum, so that is 1. So that is how this has created 132 pattern. I mean the pattern like this, 1, and then we got peak, that is 9, and that is here it is 8. So 8 is coming between 1 and 9. So this is a 132 pattern, and of course our method will return true. This is how we are going to implement it with stack. Let's code it up. First thing first is variable, and initialize it with integer dot min value. Then create a stack of integer, and traverse from right to left in an array. And if we found some case where nums of I is less than second maximum, we will return true, neitherwise while a stack is not empty, and stack dot and the nums of I is greater than stack dot peak. we will compare it with a second maximum, and what will be the greater, we'll give that value in a second maximum. So my dot max of comparison with the second maximum already stored in an array, and the element we are going to pop from the peak of the stack. And otherwise we will just simply push, like if it is less, then we will just simply push it in a stack, and if we got the answer, it will return true over here. Otherwise our method will return, if we will not get any 132 pattern, our method will return false. Let's run this code. It's working. Let's submit it. It got submitted. Now let's talk about the time complexity. As we are traversing from right to left in an array and doing the push and pop operation in the stack, which take O of 1 time each, like pop operation take O of 1, and the push operation also take O of 1, and that we are doing nums of length dot 1 time. So the time complexity is O of n, and as we have taken this stack, so yeah, our space complexity is also O of n.